Okay, around this time of year, well, previously on 08120, a good-looking and mild-mannered lecturer set an exam which a whole bunch of students went and took. Then said lecturer spent more time than he's happy thinking about, marking all the aforementioned examinations. And once he'd done that, he had a pretty good idea of where people went wrong and what they did. And what this little session is all about, really, is putting that down in a form that you can use to help you revise whatever happened in the marking. So I've got this. There you go. Got a view of all the stuff. And I'm going to go through every question in turn and basically tell you what I think you should have put. And yeah, then you'll know, and I'll know, and everyone will know. It's Sunday morning here. The weather's lovely, by the way. I'm sitting inside in my little darkened room. If you hear someone mowing, it's not me. I've done mine. Anyway, right, okay, to the plot. Question 1 usually starts off with something easy you can knock out of the park, unless you overthink it, in which case bad things happen, of which more a little bit later. But here we go. We've got a class called account, which is going to hold bank stuff. It's got a private data member called name, which is sensibly named. It's called name. A method called setName, and a method called getName. And the data has been made private, and the methods have been made public. And question 1, part A, says, what is the effect of making the name member private? Now, what this basically means is that only code inside the account class can see and manipulate this variable. So that means that users of the account class can see the setName method and the getName method because those are public, but they can't see the individual name. Now this is to stop. Well, you can't stop someone fiddling with the name because they can always call setName to put a value in it. What you can do, though, is get control when the name is fiddled with and make sure that sensible things happen to it. In other words, the effect on the users is that they can only use the setName and getName methods. They can't see the name property itself. And the reason you do this is not to stop someone putting a stupid name in there, but to make sure that any stupid name that you put in there agrees by the rules of the account class. In other words, it probably should contain letters, it probably shouldn't be empty, and blah, stuff like that. So correct answer here, 2 easy marks. The effect of doing this is that classes outside the account class can't see or manipulate the name property directly. They have to go through the 2 public methods. Pretty much everybody got this. So if you put that, award yourself a pat on the back, unless you're a cow. Pat on the back, cow. Okay, fair enough. Unless you're, and then move on to the next question, which is slightly more tricky, but not that much really. So let's scroll down. It should not be possible for an account to contain a name that is an empty string. Explain how the program could be changed to enforce this requirement. Now, pretty much everybody got this. The key to understanding how these things work is looking at the way in which the question is building on the previous piece of code. And so the best answers, the ones that got the most marks, focused on this setName method here, whose job it is to set the name. Now once you figure that out, what you then say is, okay, name is private, so only the setName method can be used to touch the name from outside this class. GetName will return a copy of it, but that's another story. So setName is where you put the action. So anyone that said we put a condition inside setName which checks for an empty string and refuses to set the name if the string is empty got close to full marks. Some people said it should write a message to the user saying your name is invalid. That's not really sensible because setName is happening inside the account class, and this might be happening on a server 10,000 miles away from the user who's typing in the name on a web page. So printing out a message on the server console won't really help them. So your best bet here is to do one of 2 things. Either make a setName method which returns false, which means that I didn't like your name and I've not set it. Ha! Or make a setName method that blows the entire program up, which means I didn't like your name and I've taken your computer away. Ha! Now, the throwing exception one I quite like for this one because it basically means there's absolutely no way that you can get hold of the name. Some folk talked about constructors, some folk talked about other bits and gubbins, but basically the way you answer this one and get perfect marks is by saying setName is the thing that sets the name. Therefore, I'll put some code in there that tests the incoming name to see if it's okay, and if it isn't, I'll make something bad happen, which could be not setting it and returning false, or not setting it and blowing the program away. Either way, that's your 5 marks. Keep going, Rob. Okay, so explain the effect of the following code. Okay, account A equals new account. So, first things first, you must explain the effect of the following code. If you don't do that, a couple of marks have just gone. So read the question when you're answering these things. Don't just dive in and come up with the answer to the next bit. Explain how the code in the account class could be modified. So first bit, this makes a tag called A, which can refer to an account, then makes a new account. That's what this line here does, and sets A to refer to it. So what we have at the end of this is an account tag called A, because account is A is a reference, which is tied to a brand new shiny empty account. Lots of people said that. Lots of people got good marks for saying that. And then we go on to the next bit, how this code in the account class could be modified to the name of the account. Okay, so we're talking about constructors here, in that what should happen is you should give the account the name you want it to have when it's created, and you do that when you call new. And so a perfect answer would put a string of text in there, new account Fred, say, and that would be picked up by the constructor. And again, because these questions link together, the simplest thing to do is to call setName to do the heavy lifting for you, because setName does the validation, it does everything, and if you've got the exceptions in there, it causes the construction process to blow up if someone tries to make a badly formatted account instance. So that would kind of be the answer that I'd be after, and that would be, in my opinion, quite a good way to do it. Anyone that said we put a constructor in here, anyone that said it takes a string and we set the name to that, will be getting close to full marks. For absolutely perfect marks, you kind of roll the system back in on itself and you call the setName method, which does all the work for you, and validation as well. So that will get you 8 marks, and jolly good. And so you can be quite pleased. Oh, here we go. Question 2, overloaded. Now, quite a few folk got this right. Quite a few folk confused it with overridden, which is class hierarchy type stuff, and quite a few people, I think, put that down because they wanted to try and get some credit for having learnt something, and if it was the wrong thing, then so much. So what? Well, so what? You don't actually get the marks for that. Overloaded is the one where we have methods that have the same name but different signatures. So you've got several different ways of, say, to pick a task at random, creating an account. And quite a few folk went, oh yeah, this is kind of following on from the previous bit, and I could make a constructor for the account called account, because that's what all the constructors are called, and it could take the name. The second one could take the name and the balance. The third one could take the name, the balance, and the address. So now I have 3 constructor methods. One takes a string, one takes a string and the decimal for the balance, one takes a string and another string for the address, and decimal for the balance again, and so on and so on. So the correct answer to this question really was that if I overload something, it means I provide a method with the same name but a different set of parameters, because I'm doing the same task but the information going in is subtly different. And you could use the account as an example of that. You could use setting the date as an example. Some people did that because the date, hour, minutes, seconds, day, month, year, number of minutes since 1st of January 1980, blah blah blah. There's lots of different ways you can make a date, and each of those could have its own set date method. So anyone that covered that got good marks. Anyone that told me all about overriding objects in methods in child classes got zippo nada. I'm sorry, it's just the way it is. Perhaps overridden will be okay next time. Who knows? Then again, maybe it won't. Moving on. Okay, threads. Okay, everyone had fun with threads, and some folk got the answer right. What's a thread? Well, anyone that said train got a few marks for that. If you think of the program or your little statements as a whole bunch of track with semicolons between each one, chugging along, whatever, then a train is a particular a thread is a particular train of execution that runs through those statements. So pretty much everyone got that. A few people talked about all kinds of waffly things about multi-core CPUs and processors overheating and all kinds of bonkers things that didn't get many marks but raised a wry smile, if not a scream of agony, from the person marking it. So, a thread is basically a sequence of execution that runs through a bunch of statements. So, poor design. I wasn't really talking about making tons and tons of threads and having the processor overheat and catch fire, although some people said that. Like some people said that a method that's overloaded causes the computer to blow up. No, it doesn't. It's much simpler than that, much less fun. So here, a thread is basically this thing which is going through your code, which is probably fiddling with data. And the ways in which threads cause grief is if two of them are fighting over the same piece of data, you can get what are called race conditions, where the data gets out of step with itself because the two threads have moved it around in a way that isn't thread safe. So adding numbers to other numbers might result in intermediate values getting messed around and bad stuff happening. Then the second reason why you have problems with threads is that if you try and fix that so that one thread has to wait for the other one to finish, then now you've got a situation where if two threads are waiting for each other, then your program is stuck. That's often called deadly embrace. So anybody who's talked about fighting over variables, waiting for him to finish when he's waiting for you to finish, kind of blah stuff, will get good marks. People talking about i3 processors and multiple threads overheating the thing and stuff didn't get a lot, to be honest. So kind of here we're talking about the thread. They're created as objects. So an object describes the thread, and we have a delegate which tells you, a delegate being a reference to a method somewhere. So you pass the thread, hey, please run this method for me, and the thread goes off and runs it. That's how they run. A few people got that. So it's all in the notes. Feel free to go and look at it. But basically, I wanted to know how you kind of make the thing, and people, quite a few folk, grasp the fact that it means you can do several things at once, which is good. But you need a little bit more detail than that to get your full 8 marks. Hopefully that kind of makes a bit more sense. Now let's go on to the next one. Tile warehouse. There were a few folk that got this wrong, but by a few I mean like a very small number. Everyone seems to have got this, and I was really pleased about that. Some folk, despite the fact it said draw a class diagram, didn't draw a picture, just wrote some code. That's fine-ish. You lose a mark or two for that, because if a question says draw a diagram, then what I want is a diagram. So please do what the question says, and we'll all get out of this thing alive or whatnot. Okay, so right, stock at the top with a number, description, string, items in stock and a price. Stock number could be a number, could be a string. That could be a string because I've told you it is. That thing will be an integer because you can't have half item in stock. In fact, you might even have made it an unsigned int because you can't have a negative number as things in stock. And a price, which could be decimal, could be number of pennies. I don't really care. Tiles have width, depth and height, which are so again, you could do that in any kind of numeric type you like. I don't really mind. Glass tiles contain this information in the form of a string, and buckets of tile adhesive have a particular type, which is sort of, I don't know, grout, whatever you like, and amount expressed in liters. So people drew up a class hierarchy with stock number at the top, tiles underneath that, stock at the top, tiles underneath that, and glass tiles underneath tiles, and then buckets underneath stock. Fine, perfect, fine way to get 8 marks, which is quite a big chunk of the pass mark actually. So this will give you a fifth of the pass mark if you got that diagram right, and a lot of you did, and I was very pleased to see that too, because it means you can design classes, which is nice. So B, building on this, we want to know the date the stock item was last sold. This is so they can detect stuff that hasn't sold for a while and think in terms of dropping the price. Right, again, everybody figured out we have to store the date somewhere, or at least quite a few people did, and so where's the best place to put the date? Well, turns out best place is to put it in the actual stock class, because that's at the very tippy top of the hierarchy, so everybody will get it. Some folks said we put the stock item in the tile and the glass tile and the adhesive. You put the time in these things. That's kind of wrong. What I really wanted to see this is actually in the parent class. And some folk actually figured out it might be kind of funky to have a flag that said whether or not you'd apply the discount or a discount percentage or whatnot, which you could fiddle with. That all kind of made sense and got them good marks. But the bottom line here is that somewhere in the stock class, right at the very top, you have a thing that is a date and a time when you last sold one of those. And then that means that you can go through knowing the current date and when you last sold it and figure out if more than 6 months or so have gone by, then you can do things with discounts. So that's kind of what that's about, and that gets you your 5 marks. Let's keep going. The customers told they have no idea how many different items. Yeah, okay. What that means is that he's got tiles, he's got glass tiles, he's got buckets of adhesive, he's got, I don't know, those spatula type things, the spacing things, all kinds of other bits and pieces. I don't know much about tiling, as you'll probably recognize if you see my bathroom. My bathroom looks fantastic, by the way. It's because somebody else tiled it. Moving on. So, how do you deal with this? Well, a lot of people got quite carried away with the complexity of this, and that's fine. It's also a bit silly. All I really wanted to say is that I'm going to put my parent class, the stock class, which effectively is everything, in a list. So I have a list of stock items, and if I have a new kind of tile comes in, I don't know, perspex or polymer or, I don't know, granite, who knows, then I add a new stock type, which is a child of the main stock class, and that then goes in the list of everything else. And so now I've just got, I can keep on adding new types of stock, and because my list is of stock items, the parent class, it doesn't matter. And if I want to know how many items, different items I've got, then I just ask the list, hey, how long are you? Count how many things there are in there. Now, there's a very important distinction here that you have to bear in mind. What I'm asking about is not how many of a particular item I've got. In other words, how many grey tiles I've got, 6 inches square. What I'm asking for is how many different kinds of tile, adhesive, spatula, Lord knows what, I've got in there instead. So the correct answer to this one, and a few folk overthought this, but I gave them marks for having a crack, is basically to say we'd have a list of stock items. And if new stock items come along, we add them to the list. And then if we wanted to, we can spin through that list and count the total value of the stock, find the thing we've got the most of, find the oldest thing we have in stock, blah, blah, blah. Do all that. Okay, so correct answer here, a list of stock items. Okay, 5 marks. Easy peasy lemons. Okay. Abstract classes. What does abstract mean? Well, it means standing back. It means talking about things in general terms. It means not actually focusing on specifics, but talking about stuff like stock rather than stuff like granite tiles 6 inches square. So, the best class, pardon me, that was awful. No apologize. The best class to make abstract, in fact the only class I'd make abstract, would be the stock item one, because everything's a stock item and that's how you want to deal with things. Some folks said the tile class could be abstract because it has this child class, which is the special glass tiles. Please don't do that. It's not much of a plan really, because you want to make tiles and you want to make glass tiles, and as soon as you make a class abstract, one of the rules of the game is you can't actually make one of those anymore. So correct answer here is that the stock class is a perfect candidate for being made abstract, because you're never ever going to need a stock item. You're going to make tiles, you're going to make buckets of adhesive, you're going to make spatulas, whatever they are, and whatnot, but you're never going to make a tile. That should be abstract. That's what your list of stock will be made up of, stock items, and so it's not really talking about any particular thing, it's talking about a particular type of thing. So making it abstract, good plan. 6 easy marks. Wonderful. Okay. Explain what it means when a member of the class is made static. Okay, here we go. Leans back in chair. Static. Pretty much nobody said it means you can't change it, which I was very pleased to see. Pretty much everybody said static means that it's created and it's part of the class, not any particular object. And lots of people said things like, in a bank, the maximum and minimum age of your customer is something which is held across all the accounts, so why not make it a static member of the account class? And 1 or 2 people said it's useful because you can make a method which is static, and then it can be used without making a class instance. And it talked about things like mathematical things and whatnot, and that all gets you good marks as well. So really two reasons why a class will contain a static member. One is you want to have a value which is common across all the instances of the class, and things like maximum minimum age of bank account holders are perfect for that. And some said, yeah, I want to have a method which I can use like sign or cos, which is just a method that's part of a class. I don't want to have to make that class just to find the sign of a number, and so I'll make the method static, and all's well with the world. So those, yeah, okay, that's jolly good, isn't it? Okay, let's move on. Interfaces. Okay, that's question 2. So by now we're cooking with gas. We've got nice grades. Question 2 was very popular, and the grades for that one, generally speaking, were actually quite high, which was rather nice to see. Question 3, interfaces. Now, yep, a few people said interfaces provide you with buttons and windows and stuff like that, and isn't this good? And the answer is, yeah, it's good, but it's not right. I didn't want to know about user interfaces. I specifically say C# interfaces, not Abstract Window Toolkit or XAML or anything like that. I just said I want to know about the programming thing, and a few of you said that an interface was actually a list of promises, and I quite like that as a way of describing it. So effectively I have an interface which says, hey, I can give you a string you might want to print, or I can give you the number of pages it would take to print me, and you can put these in an interface, and then anybody that wants to print stuff can print you as well, because it can say, hey, give me that thing you want me to print, and it'll call the method to do that, and it'll say, hey, how many pages do you take to print, so it can reserve space or whatnot. So an interface is basically a bunch of things that I can say, hey, I can do that, and if I implement the interface, it means that I've got all the methods that the interface contains. So in this case it will be, give me the string you want to print, and how many pages do you need to print yourself. And so the idea here is that we're componentizing, because we don't care what that thing is that we're printing. It might be a bank account, it might be an invoice, it might be a statement, it might be a rather nice picture of one of the members of staff of the bank. Who knows? But the idea is that as long as we can ask it for these behaviors, we don't care what it is. And it's a step towards components. Class hierarchies let you reuse code. They let you actually build up stuff and make use of code in parent objects in the children, and then modify the bits that you want. They're great for that. Interfaces let you treat an object in terms of what it can do, and so you can actually pull in an object and say, hey, give me your printing details, or hey, give me your whatever, and then it'll just tell you, and you don't care what it is, but you know that because it implements that interface, you can treat it as one of these. So it's looking at things in terms of what they can do, not what they are. And so yeah, printing, folks pick that one up, and abstract methods that you don't need a class to actually work with, that's actually in there as well. So that's all jolly good, and any words along those lines get you your 8 marks, and good luck to you too. Right, question 3. Ask me to print the scores of golf players for a customer. Okay, might be a golf club, I would think, in that case, looking likely. So what do we do? 2 lists of players, one ordered by player name, other ordered by score. How do we use references to good effect here? Well, a lot of folks spotted that a reference is a tag. A tag is tied to an instance somewhere in memory, and if I have a list of references, all I have really is a list of tags, each of which is tied to an object in memory. Fine. If I order that list in a certain way, then the objects in memory stay where they are, and the list just has the appropriate arrangement. And the key to understanding this is you have 2 lists. 2 lists of tags, and the people that got full marks, all 7, drew this up as 2 lists in memory of tags pointing to lumps of objects somewhere else. And they said that if we get a new golf score value, we just slap it in the lists in the appropriate places, and everything else stays where it is. So you can actually manage your lumps of data simply in terms of a whole bunch of tags that you can order how you like. So the answer to this one is we create lists of references, and because a reference is a tag, and quite a few people wrote that in large friendly letters, 1 or 2 of them, then because of that, then we can shuffle those around and order them how we want, And as far as the sorting is concerned, that works very well, but the objects themselves, which could be huge, but in this case aren't that big, wouldn't actually need to be moved. Some folk talked about separating off and storing the scores and the name separately in separate classes. That's kind of silly and not what I'm after. What I'm really after is basically one copy of every single object, but two lists referring to those objects. And a lot of you made the point that you can have as many references as you like to an instance, and that's kind of how this works. So that's pretty much it for my bit. Yeah, I went into the question text and the enigmatic and magical stuff about testing and whatnot that I didn't do. So I'll call a halt at this point. I hope that was kind of useful to you, and I hope it's actually recorded. Okay, until next time, bye bye.